And now I'm ready to feel your hand, to lose my heart on the burning sand. And now I wanna be your dog. And now I wanna be your dog. And now I wanna be your dog. Well, come on. Woo.
Okay, so to continue from last time or last week, we were working on the basics of basic input-output program, and then we went on to variables, and now we're on operators. Just to remind ourselves what we were working on, there are various algebraic operators for addition, subtraction, multiplication, and division. You do have to be careful, though, because when you work with integers and integers, the result has to be an integer. And so if you are doing, multiplication, division, or multiplication, addition, subtraction, there's no problem there. But when you divide two integers, right, it should be a fractional value, but it's not because the fractional part gets thrown away. That's called truncation. And so you end up with 0, right, in this particular case. You can solve that problem, and I think we did this, but I lost the code for it. But you can solve this problem by simply just using what's called an explicit typecast. And again, the idea of this is that for the purposes of this division, treat b as a double, right? It's not changing b. b is still an integer. You can't change it because it's statically typed. But for the purposes of this expression, treat it as a double so that we preserve that fractional part, and when it gets into the variable c, then it's 0.05 or 0.5, right? It also follows the well-known PEMDAS. All right, if you've never seen that acronym before, it stands for parentheses, exponents, multiplication, division, addition, and subtraction. Those are the order of operations that we're all familiar with from grade school math, right? That multiplication is evaluated before division. As a consequence, the following are not equivalent, right? If I say A times B plus C, right? That is not the same as A times B plus C if I put those second two into parentheses, right? I could go to the, is not the same. I'll go to the next line there so that it's not cutting it off on the right-hand side there. Why is that different? Well, it's different for the same reason when you write out math. PEMDAS, parentheses, interrupt the normal order of operations and makes it so that that addition is done first and then the multiplication is evaluated. Otherwise, it's all left to right. That first one, it will multiply A times B, and then after that's done, it will add in C. It is not the same thing as adding B and C together and then multiplying by A. So you do need to be careful, and in fact, even if you don't need to, I would recommend putting in parentheses. So for example, let's come over here, and let's go ahead and define 3 coefficients. Remember, these are not great variable names because they're not describing what they are. But they're okay for us because we're talking about things in general abstractly. Int A, B, and C, 20, 30, and 10, 20, and 30. Let's go ahead and try to, here, let me go ahead and write it out in math. Example, what if I were to write out the following in just plain old math? X is equal to fractional of 2a on the bottom, negative b plus minus square root of b squared minus 4ac. what am I trying to, is that right? Square root. Sorry. Let me reformulate my mathematics there. There we go. All right, what am I trying to compute right there? The quadratic formula. Let's translate that to math. First of all, can I have plus minus? Probably not. Can I write in plain old code on a QWERTY keyboard this radical sign right here, the square root sign? No. Can I write a numerator and a denominator and split them? No. So let's go ahead and translate this to code. First of all, is my root going to be an integer? It could be if I get lucky, but probably not. Most roots are going to be what? They're going to be fractional. So do I want an integer here, or do I want another thing? A double. Right? Okay. Here's my first root. Negative b plus minus square root. How do I do a square root? SQRT. Okay. SQRT. And that's going to be a special function in a library. Right? It's going to be bringing a calculator into the mix here. It's not in the standard library because it's math. It's not in the input-output library because it ain't input-output. It is math. So let's go ahead and include the math library so that we can do things like square root. SQRT is short for square root. Why? Because 50, 60 years ago, if you could get away without having to write out square root as the full term there, you did it because that's saved on memory. To this day, every single programming language that I've seen, you don't have that memory constraint anymore, but they still go with this abbreviation SQRT. Why? Because it's familiar. All right, square root of b squared. Sometimes people write it like that, minus 4ac, all over, remember I've got that division there, 2a. Right? Now, this is completely wrong, and there are lots of problems here. You're going to help me fix them. Let's start reading left to right. First of all, negative b, you can do that. If b contained the value 5, now it contains, now that for the purposes of that expression, it's negative 5. If it contained negative 2, now it contains, or it doesn't contain, but now it has the evaluates to positive 2. 0 stays 0, and there is such thing as negative 0 in code, right? But it's the same thing as 0. Okay. Plus minus, you can't do that. This is mathematical shorthand for the fact that there are actually two roots, right? So if you want to compute both roots, you need two variables. You can't hold two values in one variable. Right? So let me come back over here and rename this. Root 1, right? Now, it's bad practice to have, say, variable 1, variable 2. I need another one, variable 3, variable 4. You have no idea what those stand for. But root 1 and root 2, I can't think of any better names than that. Right? In fact, there's an old adage in computer science. There are only two difficult things in computer science. One of them is cache invalidation, and the second one is naming things. Right? So it's good enough. Right? I'll go ahead and go with the plus root on this one. Right? And if I want to compute the second root, then I will need the minus root. Okay? For now, let's move on left to right. I cannot do this in C. In fact, most programming languages. In fact, you can do this, but it doesn't mean what you think it means. What am I trying to do? I'm trying to say b squared, b raised to the power 2, right? And the caret has a very special meaning that we're not going to get into because it's part of what's called bit twiddling. It's an exclusive OR, bitwise exclusive OR operator. In other words, it will compile, it'll run, it'll give you completely different results that you don't want. Right? So how do I change b squared into a simple mathematical expression? Yeah, b times b. Right? That's as simple as it gets. If, however, you do need to raise, say, b raised to the 1/3 or b raised to the 0.12566423 or whatever, right? There is another math function that allows you to do that. Pow, short for power. Raise x to the power y. In this case, I want to raise b to the power 2. Now, it's not necessary in this case. I'm showing it to you because I need you to understand that there's a lot more stuff in the math library that you can use. This is not the best solution. B times b is probably the best solution. In fact, the compiler is smart enough to see you don't need that. I'm going to go ahead and replace that with b times b for you because it's more efficient. Right? Whichever one you do in your code, that's up to you. Right? Just be consistent about it. All right, minus 4ac. As the italicization is showing you here, this is probably not correct, right? You can't write it like you would in algebra, 4, no space A, no space C. Instead, what do I have to do? 4 times A times C. There we go. All right, there we go. Likewise, 2A on the bottom in the denominator here, 2 times A. Now, is that correct? Remember, put on your PEMDAS hat. Yeah, I don't have a numerator-denominator relationship here. Everything in the numerator on the top needs to be grouped together. Right. There we go. What about the denominator? Yep, need that too. I was very generous with all the white space that I was putting in. If you want to bunch things together, make it a little bit less readable, more readable, that depends. Just be consistent about it. For example, you may not want all those spaces around there, right? Well, if you don't want that, then why did you do this, right? So just be consistent about it. I'll be consistent about it and always add in more white space than I need to because it's a little bit more readable. If we want that other root, I will need to create that second root, root 2, and make sure that I am changing the proper one. Which one was the proper one, by the way? Oops. Go back to terminal here. All right. I just committed a coding sin. It's called copy pasta, where you copy one piece of code and then you just simply paste it without too much thought. Okay, well, I'll go ahead and change the variable name there. Right? Now, because I pasted it, right, I forgot that other crucial change. What other crucial change should there have been? That one right there. Right? You will get in the habit of copy, paste, copy pasta, and then forget one of those crucial things, right? And then that leads to bugs, and that leads to what's called spaghetti code. That's why we call it copy pasta, because it leads to spaghetti code. Spaghetti does not look pretty, right? It's tasty, but well, you can't tell one noodle from another noodle. You can't tell when one noodle begins and when another noodle ends, right? So don't get into that habit, okay? All right, great. Let's go ahead and see if this actually compiles now. GCC demo, right? Uh-oh. It doesn't know what pow is. It doesn't know what square root is. It doesn't know what any of these things are. This, unfortunately, is an artifact of history. If you're interested, I can point you to an FAQ on why it is like this. Basically, remember all the way back at the beginning here that I told you that there was a chain of events going on under the hood. We go from our source code to a preprocessor to assembly to machine code, and then the other piece of the puzzle here is that it goes out to these libraries and links them in. I'm using printf. I'm not using it right now, but I will. I'm using printf and scanf. It takes the code, the machine code from that library and links it into my library. It takes that math code that's already compiled and links it into my library, but it doesn't do it automatically on some systems, in particular, the one that you're using. So what I have to do is I have to say, link in the math library, LM, -LM for short. And when I do that, now the compiler understands, okay, you want to bring in the math library. Why didn't I have to do that for the standard library and the standard input-output library? Because those are standard libraries. Well, math, that seems pretty standard to me. I would argue and agree with you, yeah, that seems pretty standard to me, but 50 years ago, they didn't think it should have been that standard, and so we're living with that to this day. Right? So just understand that if you see a message like this, oh, yeah, that's right, I need to link in the math library. In all of your handouts that we give you, we do give you reminders about this. And some systems, it's not even necessary because the configuration has been changed to make it standard. But on this one, on the CS50 IDE, on Ubuntu in particular, it is. Okay? Let's run it. No news is good news, right? There's no input, there's no output here. So let's make some output. Printf. The roots of ax squared plus bx plus c are root 1 and root 2. Right. There we go. And I will end the line to make it a little bit prettier. There we go. Now, is that actually going to output anything? Well, it's going to output this message that I just wrote. Is it actually giving me those numbers? No. I didn't put any placeholders in here. So let me go ahead and put in a placeholder for A here. % D or F? D, because for now, I've got integers here. %D and D plus C, sorry, and then %D r, and then I will replace root 1 with %f because it is a floating point number, and %f because that's a floating point number. Let me try to compile this at this point. I'm going to get a warning. Why? I'm going to get lots of warnings here. Why? I provided 1, 2, 3, 4, 5 placeholders, but did I specify what would go in those placeholders? Nope. And that's what it's warning me about. It's saying, wait, there's a placeholder here, but you didn't give me the variable. So if you've got 5 placeholders, you need 5 variables. If you have 4 placeholders and you give it 3 variables, it'll give you a warning about that. If you have 4 placeholders and you give it 5 variables, it'll give you a warning about that. Make sure that it's matching. A, B, C, root 1, and root 2. There we go. And when I do that, there. Now it compiles without any errors. Let's find out if it gives us the values that we're looking for. Nan and nan. So the roots are grandmothers? No. So pull out your calculators and try to do this. Right? Try to compute the roots of a quadratic equation 10, 20, and 30 for the for those coefficients. What are you going to get for this thing right here? B squared minus 4ac. You're going to get something negative. Right? Can you take the square root of a negative value? Well, you can if you use complex numbers, right? Imaginary numbers, right? But that's not how it works in code. In code, imaginary numbers, complex numbers are not numbers. That's what this is. NaN stands for not a number, right? So be careful. Some math stuff. More math, right? So just as a reminder, sometimes you may need to compile with the LM flag to link in the math library. Some math expressions are invalid. For example, if I go with, let's go to LaTeX mode here, square root of -1 is not a number, or nan. Right? What about, say, other things like, say, if I tried to divide by 0? What if I did 10 divided by 0? Could be, if you're taking calc right now and you take the limit as you approach 0, on as the denominator approaches 0, it blows up. It becomes infinity. So it could be inf. There is a keyword, there is an infinity type, right? Or it could cause a program crash. In fact, that's what it does in this case. Let me show it. Let me show you. Down here, let's just go ahead and create another variable, int, or let's go double y is equal to a divided by 0. Right, there we go. Let's try to recompile that. All right, finally, it's already warning me about that. It'll actually not be smart enough to find that out if I say a is equal to 0, and then I divide, or not a is equal to 0, but let's go with b is equal to 0, and then we go divide by b. That's still division by 0, but it's not smart enough now to figure that out, right? Because I'm using a variable. I tricked it into not warning me. Now let's find out what happens. Floating point exception core dump, right? It died, right? Anything after that would not have worked, right? If I said print f, almost done, ... Right? And the line, I don't think that this would have been printed because it would have died before then. Right? Yep, it didn't get printed. The program crashed at that point and ended, right? With an exception, right? So there are things that you cannot do with the math library. Other math functions, right? So we've already seen square root and pow, right? Pow, this is power. Right? But you also have other things. If you just look on your calculator, the common things would of course be sine, not sine, but sin, cosine, right? Why didn't they write them out? Well, for the same reason that they're not written out on your graphing calculator, because it's shorthand, it's an abbreviation. Tangent, etc. So how do you know what might be available to you? We have an expression called RTM equals read the manual. And what that simply means, modern translation, use Google. There we go. So what is the two-argument arc cosine or arc tangent function? What is the natural logarithm, et cetera, right? You just search for that C math library logarithm, right? And you'll come up with the documentation. RTM. Read the manual. Right? Okay. All right. This is good for now. Any questions so far? No? All right, then. Let's go ahead and complete this program. I don't always want to use 10, 20, and 30. Let me go ahead and erase those. And first of all, should I have chosen integers? Are you always limited on your quadratic formulas to 10, 20, 30 whole numbers? No. So let's go ahead and change those to doubles. Right? Double B, double C. One way that I could have written this a little bit shorter, more terse, would of course be to A, B, and C. Right? Now it's all on one line. Okay? I'm going to prompt the user for those inputs instead of hard coding them. When I put in that this is equal to 10, I was only making this program for one use, for those particular three values. If I wanted to change them to test this program, I would have to go back, change it, recompile it, rerun it every single time. So what I'm going to do is I'm going to prompt the user for those inputs. This is an interactive input, just like we saw with the kilometers program. Printf, please enter A. We'll be really nice about it. Please enter, please enter. Now remind me, what's the other thing that I use to read in from the user? It's going to prompt you. It's going to sit there, dot, 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 until you actually type something on your keyboard and then hit enter. Right? So what's the other thing that I need to read it in from the user? Scanf. Right? And F stands for formatted. Now I'm going to read this into a variable A. Right? I'm not done yet. What is my placeholder for a floating point value? When I use printf, it is %f. But when I use scanf, it is %lf. Right? Also, I'm missing something here. That's okay. If I forget that I'm missing something, I don't remember what it was exactly, but at least the compiler is smart enough to say that there's something wrong here. Right? There's something wrong way up here in my scanf. It expects a double star. I have no idea what a star is yet. That's a pointer. We'll talk about those much later. I expected something of type double. Just for now, remember, oh yeah, there's that magic thing that has to go in front of the variable. What was it? An ampersand. There we go. Again, I'm going to commit that coding sin and copy, paste, right? And then change stuff. B, all right, B, and then C, and then change that one to C. And you see the trouble that I'm getting into. What did I forget to change? The other one right here, right? So either get in the habit of making sure that absolutely everything is changed as you go along, or don't get in the habit of using copy pasta techniques. Okay? All right. Let's see if that worked. GCC. Oh, by the way, I changed those from integers to doubles, so I need to change these placeholders now. F and F. Otherwise, it's just warnings. Right? There we go. It compiles with no warnings, nothing. A.out. Please enter A. Well, let's find out if I'm reading those things incorrectly still. 10, 20, and 30. Oops. Ignore that for now. We'll come back to that. There we go. 10, 20, 30. All right. Not a number, not a number. Almost done. I should have taken that out, but whatever. All right. Let me go ahead and take this out now. Why is it not crashing on that? I don't know. Oh, because B is no longer 0. I don't know. I took it out anyway. Right? All right. Again, 10, 20, 30. It gives me not a number, not a number. Right? How could I have checked for that? Oh, I'm about to take the square root of -1. I probably shouldn't do that. Instead, I should do something else. That means that you need to make a decision. Right? If I'm about to do something dangerous or illegal or invalid, maybe I don't do it. I do something else. Versus, oh no, everything is perfectly fine. I do something else. That's going to be our next topic starting on Friday of conditionals. Here's a condition. Am I about to divide by 0? Yes? Okay, then don't do it and echo an error message instead. No? Okay, it's perfectly fine. Go ahead and divide. Do whatever you want, right? Continue. I need to branch out and make a decision. That's going to be conditionals. If one way, else a different way. We're not there yet, though. All right? You can pull out your calculators and give me a value that would be okay with this. I just need to make b really large and the other two really small. 1, 4, 1. You can pull out your calculators and see if that's correct. That looks correct to me. What else would be could go wrong here, though? What else could go wrong with this particular equation right here? Right, yeah, square root of negative values. Division by 0. What if a is 0? Let me try 0, and then 4 and 1. What do you think is going to happen? Crash, or in this case, I just got that inf, right? Anything can happen. It's a crapshoot, right? You're gambling. It's undefined behavior. Whatever the compiler did, whatever the standards say, right? Not anything could happen. Anything goes. Right? In this case, I got a negative inf because I was dividing by 0. Right? Why didn't I get a negative inf on the other one? I have no idea. Right? Again, anything can happen. Right? By the way, if you do have a as 0, you don't have a quadratic. You don't have a power 2 polynomial, right? You don't have a quadratic. You have a linear, right? And then what you could do is say, oh, I'm about to divide by 0. Well, they must not have a quadratic equation there. Instead, they have a linear equation. I know how to solve those and go off and do this other logic over here. Right? Again, conditions. We need that. Oh, we'll start that on Friday. Okay. What else could go wrong? I gave you a preview of it. What if they just simply sat there and mashed their keyboard, right? Or they spelled it out. 1. Is that 1? No, they weren't giving you any actual values here. So what happens? Well, it depends on how you set this up. Interactive input is very, very error prone, especially when you have PEB-CAC users. Right? So PEB-CAC, what is that? Problem exists between the keyboard and the chair. Right? So you have a user here that you please enter in a number, right? And if they refuse to give you a number, there's not much you can do, right? I mean, you could program a much more robust program that checks to see, did they enter a number? No, they didn't. Okay, reprompt them until they behave. Reprompt them. If they keep mashing their keyboard, that's on them, right? I would just quit on them, actually, and say, please run this again some other time. And that's what usually programs do. More modern interfaces, like a web form or a graphical user interface, will deal with this by having some programming in the background that if you have like a telephone number thing, text input, if you start typing in non-numerical characters, it won't even register them. And you see this all the time in well-designed web apps or whatever, where you're not allowed to put in bad input. Or if it says, please enter a number between 1 and 10, right? Those are your only choices. You can't just arbitrarily just type something in. You have a little scroll bar here that you can choose one, or you have an up and down arrow that you can choose one. Or you can type it in, but then it replaces it with a value, right? That's a whole bunch of input validation that is intended for end users, for PEB-CAC users, for human users. Here's a secret, though. The vast majority of software is not intended for human consumer users, right? If you look at software as an iceberg, all the consumer stuff, when somebody thinks about computing, they think about this, their phone. They think about nice, colorful graphics and stuff like that, games, right? But the vast majority of software is under the ocean. It is designed to interface with other software. Why? What's the whole point of software? To automate stuff, so that you don't have to do these mundane tasks. The vast majority of software is written to interface with other software, which is written to interface with other software, and get stuff done automatically. You don't have the typical software here of, please enter a number, okay, 43. Please enter in another number, okay, 76, right? You don't have a human user sitting here between the keyboard and the chair. Instead, it's usual to have what's called non-interactive input. Right? That's where we're going to look at now. Right? So interactive input, in other words, using scanf, prompting the user, makes the program pause and wait for a human user to enter their input. Right? Most programs are not like this. Most programs are non-interactive because we like automating stuff. That's the whole point of writing programs, of writing software, to automate things and not be interactive. So from the command line, you can actually input things non-interactively using command line arguments, or CLAs for short. Right? Command line arguments. You've already seen it before. I just didn't tell you that they were command line arguments. How did I compile this program? Did I say GCC and then GCC sat there and said, okay, what program do you want to compile? No. Instead, I said demo.c. Did it say, okay, do you want to compile with the math library or not? Yes or no. Please enter Y or N. No. It was not interactive. Instead, I provided this flag value here. Those are my arguments. GCC, I want you to compile this thing with this flag. Get it done, right? Non-interactively. I don't want you to have to ask me each and every single question. I want it done now. And those are the command line arguments. Likewise, I could run my roots program here by saying 1 for 1. Right? That'd be nice. Then I don't have that interactive back and forth. How do we do that? All right. CLAs, command line arguments, are provided when you start the program. So a.out, hello, 10, and 3.5. Those are just placeholders for now. I'm showing you the fact that you can give it strings, characters. You can give it integers, whole numbers. You can give it floating point values. Right? This example has actually 4 command line arguments. Right? Count them. I see 1, counting backwards here, 2, 3. The a.out is a command line argument. That's the executable file name. That's always the first argument, in fact. The first one is always the executable file name. The first argument is always the executable file name, right? In other words, in our case, and in most cases, it's going to be a.out with the // right? Inside your program, you have access to all of the arguments through the argc and argv arguments, right? Let's come back over here and take a look at our program again. Remember when we were looking at the anatomy of a program and I pointed these things out? What are those things? Argc, argv, magic. Now they're no longer going to be magic. Argc is the number of command line arguments that was provided. C stands for count. Argv are the actual arguments that were provided. V stands for vector, right? So argc is a count of the number of arguments. There we go, arguments. Argv is, and this is a preview of arrays much later, is an array of the arguments. V is for vector. Don't ask me why they chose vector instead, right? It's an argument list, right? So you can access this using numbers. Argv sub 0 is the executable file name, right? Otherwise, after that, you can go with argv sub 1 is the first user provided argument, right? And likewise, you can keep going. Argv sub 2 is the second, right? ... Right? And in this case, we've got, say, 3 user-provided ones, A, B, and C. But that means that to accommodate that executable file name, we actually expect 4. Okay? However, all arguments are strings. Right? You may need to convert them to numbers. To do that, you can use 2 functions. A to I converts an argument to an integer. There we go. So let's highlight that. A stands for alphanumeric. 2 stands for 2. Convert an alphanumeric character to, and then I stands for integer. Convert an alphanumeric integer to an integer. Excuse me. Likewise, you can use A to F. Converts an argument to a float. In other words, for us, that's going to be a double, A to F. Okay. So now what I want to do is I want to come over here and I want to convert this program from interactive input, get rid of all that stuff, to non-interactive input. I want to read them from command line so that I can do something like this. A dot out 1, 4, and 1. All right. Well, I've got my A, B, and C. If you want to convert them, I need to use A to F. So A is equal to A to F of arg v sub something. Right? So what's the something? Should it be 0? Remember, what is that? That's always the executable file name, exactly. That's going to be A dot out. Is A dot out a number that you've ever heard of? No. So it's going to actually be 1. Copy, paste, make sure that you change everything correctly. 1, 2, and 3, that all looks good. A, B, C, that all looks good. All right. Let's find out if this works now. Of course, I've got to recompile it. And let's go with A dot out 1, 4, 1. I forget what the values were, but it should give me something, right? I think that those are the same ones as before. But it didn't sit there and prompt me, and I had to mash my keyboard, prompt me again, mash my keyboard, etc. I gave it all in one go. Compute this thing and be done with it. Right? That way I could write a script. Hey, you're grading scripts, right? That when you put something in a code post, how do you think we grade it? Right? I wrote a script that pumps a bunch of input into your programs, and then your programs produce a bunch of output, and then my program looks at that output, the expected output, and reconciles those, and that's how it grades it. Right? So, non-interactive right here. Some of your stuff will be interactive, prompting for it. Some of your stuff will be non-interactive, command line arguments. Some of your stuff will not be interactive at all. In fact, when we get to actual unit testing, what you'll do is you'll write code to test other code, and then all you do is hit a button, and your code reports everything was correct, or this piece of the code is incorrect because of this reason, this reason, this reason. Right? Again, we like writing code because it automates stuff, and it makes our lives easier. This is non-interactive input. Except that what happens when we've got that same pebcac user acting poorly? So, 1, 2, 3. Right? Those are command line arguments, all right, but is this a number that you've ever heard of? Well, yes, in English, but is that an actual number? Nope. Is that an actual number? Nope, nope, nope. Let's find out what happens. They were treated as 0. The way that this works, the way that A to F works, is it starts looking at your actual input. O-N-E. Right? The first time that it sees an O, it says, wait a second, that's not a number. I'm done. What have you parsed so far? What have you found, thinking as a computer, what have you found so far? Nothing. What's the numerical value of nothing? 0. That's why all 3 of these end up being 0. Right? If you go back and you behave and you're no longer a pebcac user, 1, let's make it big though, 4, 1, 4, right? You can still have bad input here in that you will have imaginary roots, but at least you've got numerical inputs here now. What happens if you're a real pebcac user and you don't provide any command line arguments at all? Right? Something even worse, I hope. Right? Yep. Segmentation fault, core dump. This gets into something much deeper, much later on. We're violating memory right here. We're trying to read memory that doesn't belong to us. The operating system says, nope, I'm not going to allow that. That's a security issue, so I'm killing your program. Segmentation refers to a segment of memory. A fault refers to something illegal. We tried to access memory that doesn't belong to us or that doesn't exist. The operating system detects this and says, nope, I'm killing your program, and that's why it died. Right? We'll understand that much, much later. But for now, understand that, wow, we're going to have to deal with this. We're going to have to deal with bad users, bad input validation. Here is a preview of what we're going to do on Friday. I want to know did you at least give me 4 command line arguments? Because if you gave me 3, that's not enough. If you gave me 5, that's too many. So what I'm going to do is I'm going to create what's called an if statement. If the number of command line arguments that you gave me is not equal to 4, then that's bad, right? You should have given me a.out 141. Right? So if that's not the case, it's not equal to 4, what I'll do is I will print an error message, printf error, you must provide 3 numbers. Right? There. That's intended for human consumption right there, because there's no computer that's going to read that. Right? And then I'm going to exit on them with an error code of 1. Don't worry about that. We'll look at that later. Right? I don't want the program to continue. Right? I could just print out an error message and then continue. Right? You didn't give me 4 command line arguments. What am I going to do on lines 18 through 20? It's going to end up with the same stuff, a segmentation fault. So to prevent that, I'm going to exit out of the program entirely. You gave me bad input. I am going to refuse to do anything, and I will exit. Let's see what that looks like now. When I try to do it with, say, 1, 4, 1, it's perfectly fine. It gives me answers. But if I don't provide 4 command line arguments, in this case I'm only providing 3, then it gives me that error message. You must provide 3 numbers, and then it quits. Oh, okay, what if I only give it 1 number? Nope, same message here. What if I gave it too many numbers? Same error message. You have to provide 3 numbers here. Right? So if there are any error conditions like this, you can have a conditional statement. If this condition does not hold, there's nothing I can do. I'm going to completely exit out of this program. Nope. Right? That's what we'll start looking at on Friday. Right? I'll make sure that you have all of this in the notes. And again, these are posted to GitHub as soon as I get home at night. Right? Any questions so far? Yeah, go ahead. Good question. So by default here, it's going out to 6 decimals. Do you want more or less? Less? Okay. Let's make it to what? 3 decimals? So remember those modifiers that you put in. Period. That's the decimal point. 3 after that. Right? For a variety, let's go ahead and do 4 over here. Let's do, I don't know, 2 over here, and see what that looks like now. GCC. And let's give it good input so that it actually outputs something. There we go. So there, it goes out to 3 decimals of accuracy. It goes out to 4 decimals of accuracy. It goes out to 2 decimals of accuracy. What if I did that for this guy over here? Only 3 decimals of accuracy over here. Recompile this and rerun it. Now look at the difference there. 2679, 268. What did it apparently do? Rounded up to the nearest decimal place. It did not change the value. Whatever value was stored in root 1 and root 2, those are still there. They're untouched. But for the purposes of printing, it rounded for me. Right? Likewise, remember the other modifier that you can use? I'll put an insane amount right here. I don't need that much. Let's go with 30. There we go. Let's try that again. What did it end up doing here? It ended up printing a minimum of 30 columns. 1, 2, 3 columns for the decimal parts, 4 for the decimal place, 5 for the 1, and consequently 25 spaces to pad it out to the right. Right? If you want it justified left, what did we do? Remember on Friday? We made it into a negative. And now all those spaces will be on the right-hand side instead of the left-hand side. Kind of weird, but whatever. Again, I'd be consistent about it. By default, 6 is good, right? If it's money, though, and I'm printing out, you've converted so much Bitcoin to US dollars, I should not see a $50, 12 cents, and then some additional cents, right? Okay. Yeah, exactly. In fact, you know what? We've got 5 minutes here. Let's really quickly give a preview of your lab tomorrow. It converts yen and Great British pounds to dollars. Let's go ahead and trade Bitcoin here, right? So double Bitcoin, or what is the abbreviation for Bitcoin? BTN, right? Or Big Ten Network, or something else, right? What is this telling you? Avoid abbreviations, right? Bitcoin, right? Let's call it that, right? I don't know, really quickly here, let's just go ahead and go with A to F of argv sub 1. In other words, we'll read it in as a command line argument. How do I convert Bitcoin to dollars? BTN to USD. What's the current value right now? Oh, I need some more significant figures than that. Come on. Oh no, it's not BT. It's Bhutanese. Okay. What is the code for Bitcoin? BTC. Thank you. BTC. I forgot. There we go. That's way more sensible right there. So 1 Bitcoin is worth $26,000, right? Times Bitcoin. Right? There we go. Printf. Percent F BTC are percent F, and I'll put a $ in front of it because that's what we do for dollars. And the line, Bitcoin and dollars. There we go. So let's compile that, and this is still demo. Don't worry, I copied everything over. Say I've got 10 measly Bitcoins that, what is it, 10 years ago, I purchased somebody purchased a pizza for me for 10 Bitcoin. People were doing that with whole Bitcoins back then, right? So that is $259,766.70, except that, what about those zeros? They should not be. What should I do? 0.2. And I didn't mistype. There we go. There. That's how much money I have. I wish. Now go into those landfills and try to dig out those thrown away hard drives with Bitcoin on them. Any questions? Otherwise, I'll see you on Friday because remember, Wednesday, no class, no live stream, and unfortunately no help hours because the entire campus is shut down. Yeah.